Hello, Sydney. Welcome to my YouTube channel. So today I'm going to talk about staircase design and why I normally do not use structure using a stair because it's because even if I model staircase in structure, at the end of the day, what is important is to reduce my work. I want to be fast in detail. That's true. You can design staircase, you can detail staircase as only one flight staircase. I usually I cannot design double flight staircase or axis. Even if I model, analyze, and then I don't know the I'm going to get my details, but I can go and try to model staircase here. And let us see staircase. I will use metric computer. I will make sure my metric and English. Design code. Even if I model my staircase here, I'll be having problem. For instance, let me open the new program. Then I'll create. So I'll go to geometry. So I'll create and then make it 20. Number of then I will change my spacing. My riser, my going should be 22.5, that is 15. Then my riser that is 150 then using the ice white plate let me put an so I will start modeling my stairs. So I will add my just add my beams or just insert nodes. Wait. Yeah, our beams. So I'll go up to a height of 1500. So that is up to there. Then I will select my node cursor and I'll select all the nodes. Then I will do transitional repeat. Repeat. Then to Z. Then 1.2. 1.2. Okay. Then view, see, then I can add my plates. I want to illustrate my problem doing this because at the end of the day, I just analyze and then I'm not going to be able to generate my drawings. So I need to copy this. Need to copy that. Select broadcast. Just that. Then transition will repeat. Then Z. Then 1.2. Then A. Then I'll continue adding my plates. Okay. Then maybe I can select all of these broadcasts. And then select those, and select that. Then I can go to view, geometry, try to mirror. There's mirror here, tilting. I'm trying to mirror instead of trying to mirror. Just mirror. I will mirror along x, along y, mirror along y, yx. This plane is right here is, I think, x and then y, right? Then okay, let me see. It's not supposed to do that. Go back to geometry, view, then mirror. At x is equals to so I'm going to mirror from there. Oh, I'm mirror the wrong direction. Let me see view. I'm trying to mirror. Okay, this was y z I want y z I want x y and then there. You have to just do it. So then I'm going to select all of these. Then I'm going to negative 1.2. Then okay. Then I'm going to add my plate. Then let's continue. Then and then you can see the model of my staircase. So I'm going to escape it, and I'm going to repeat this one I want to repeat this. Let me select broadcast. Then I'm going to repeat also this, also that, transition repeat along x 1.5. So I will draw my then I will select my beam cursor. I want to delete all the beams. Yes. Okay. Now I'll go to utilities, node, move open node. Okay, and then I will now go to properties. I define thickness, use 0.125, and then I will assign to view. Yes. Then I will go to my geometry. I will go to my view, radial rendering. So you can see the way my stairs look like. Now, maybe I can add a beam here, because there will be a beam here, there is a beam here, right? So I can add the beam. So I will come, and then I will geometry, from here. Let's keep it fast. Just add a beam there, 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 and then we'll come and we close, define. I want a beam rectangle 0.45 by 0.2. Then add. Then I will assign to beam, because only the beam will be assigned. Yes. Okay. Now I go and check my grading. Those are my beams. You can see the way my stairs look like. Okay. Now I can go do my analysis. I want to do concrete design, so I'll select parameters using the BS code. I'll select the ones I want to move, remove that, and remove that. Then okay. Then I will define my clear cover is 0.02 for 20 millimeters for. Then FC will be, I want to use 25, or that one is okay. Add. Then FY, and just use for 60. Then add. Use then commands and design slab element, add, take off, add, then use. Then I will clear. I will select. Let me just define clear for beam 0.025. Add. And I will select the beams. then assign. I select the plate cursor, then I want to assign with assign, and FC assign to view. Design beam, select the beam cursor, then assign. Design element, assign to view. Yes. FY, assign to view. Assign. Yes. Then I will do my analysis. I will go just add. Okay. Oops. Then I will run analysis. Okay, so this command should go below the analysis. So I will delete this command. Then I will add the command below. Then that will be the same thing. Yeah. Okay. Fine. For slab is 0.02. For beam is 0.025. That is 25 millimeters. For FC we can use just 25,000. That is 25 class 25. That is complete 25,000. And this one we can use for 60,000. That is for 60. And this one I will assign to the plate cursor. Then beam cursor. Then and add another command, design beam, add, design slab, add, take off, add, then close. Design beam, select the beam cursor, assign to the selected beam, then beam cursor, then assign, design elements, plate, assign, yes. Then and now I do my analysis. So now perform analysis comes. Save. We have not assigned load cases. Sorry for that. Geometry. Now I go to loading. The load definition. I'll start with Start with CS and go to India, then generate, go to zone 4, and okay, or general building, then medium, okay, and then generate. Medium, zone, my damping should 2%, and I generate. Yeah, my damping should be 2%. Then add close. Then I will add my self-weight, add. Remember, it's assigned automatically. Member weight, so uniform. I want for this top one, I will use 11 because remember, for the weight of the slab, we normally assign around 22 kilograms per meter, then add. So for this one, apart from this ground, because this one is going straight to the ground, when you go upward, right? There's a beam there, and a beam there. So that beam and that beam will be taking the load, will be sharing this load of 22 kilonewtons. So 11, 11. Here will be now 22. So I will continue to add, close, then add flow weights. And while remember weight, okay, flow weight. So because I think the self weight has already been accounted for, we're just going to add the live load, which is 5. Remember, there's no need to add negative in our model because this is simply CS week, so you can just range from 0 to 3. So 5. Okay. Then when put the experiment, no need add. Then let's see. And then go and assign these. So I'll select beam cursor. But there's no need to assign it because we have already modeled the beam. So this one could be maybe if there's a wall. So I think we just assign this for the wall here. Actually, this one should be around 4. Change. So this one I should delete and I'll assign this to this for the wall here. Here there's no wall. Then go back to the yes, we have added the member weight, self weight, and the flow weight. So I'm going to add for the load case, add. Now here, so I'm going to add the load cases. I'm going to add the CS first. EQ X EQ Z, and I'm gonna add that load. add live load and close. Then I'll come here, add. Just adding CSV and close. Yeah, add CSV and then close. Here add self weight, add and then go to member weight. Negative for now, negative here because acting in the negative direction. Then we're going to add the plate load. I say my plate load should be I add 2. I will add negative 5 for live load and then close. Here I can just add element I can assign to view, then I will assign to the selected bin, then I will assign to view. Okay. The other thing I could just check here. If here I got plate pressure, right? So let me see and now it this one should be live load. Now this one I can edit and switch it to 1.4. I'll change it to 1 for finishes. Then come here, add plate load, pressure, and then we'll add negative 5. Then I can remember I think we should be acting local. Then this one I can sync to it. Then I will come to my CSV. Also edit that. It should be pressure, not flow. I'll add a member element weight. That is pressure. That is I'll add negative 5. Then make it negative 6. Negative 5 just. Then add and close. Then I will assign to and go to analysis, analyze. Remember the live load was empty, we forgot about now I will so go to utilities, structure. open node. Okay. Then I need to delete the open node. Then bin structure. Node. Then structure. Bin connectivity. Okay. Then plate. Good. Select. Okay. I go to plate. Plate connectivity. I'll highlight the first. Wait first. So I'll go here, geometry, I delete the past. This also I delete the past one I've selected. Maybe no. Suppose just to go back. So I will delete this plate. So I'll go to plate. You should delete this plate down. Not essential. I'll go to geometry and remove it. Yes. Yes. Then I will save my structure. So I'll go to analysis. Okay, I will not assign my supports whether they are fixed or not. That is also very important. So I need to assign here support. So I'll go to supports. So create fix support and come here and select that and that, then assign. And come and select there and there, then assign. Yes. So here also is fixed, then assign. Yes. Then I can just run my analysis. So concrete design, okay, done. And we can go to post processing, then apply, then okay. Then I'll go to get results. I'll type maximum absolute. Then I can choose envelope here. Just to okay, and then apply and okay. Go to EQ, load, maximum absolute, apply, then okay. You can see that the structure is here. And now go and check loading diagram. You can go and check here is for dead load and change it to that is earthquake, dead load, live load, envelope. So To include the envelope, you need just to go to loading. You need to go to, let me go back to analytical and loading, then automatic generate, automatic, then release the IS of generate, then I will add, and yes, no problem. Then I will redo my analysis. Could take longer, but we have included the combinations. Data and good post processing. Yeah, apply. Okay. Then can go to plate results. Envelope. I'm going to this one, then maximum, absolute, and then apply, and then okay. So we can go and check for deflection, displacement, so moments, beam stress, and then just hit escape. Then we can just concrete design. You can go on, you can see the concrete design. So the problem here is that you can see, I've analyzed, I've seen my stairs is absolutely stable, but I cannot be able to generate my drawing. Okay, so let me go to advanced concrete designer, because I think we like this software because of making our art easier. You see, you cannot generate the drawing for that stairs, and it will give you headache, which you really prefer to avoid. You just need software. It can help you in analysis and also help you in okay, you can see from 1.5 meters, 2.7 meters, right? So you can see it. Let me create that. Because it has stairs. So I find that useless because you can see it can't do nothing without. So that's why I avoid staircase design. And even if you go to the other model, even if you go to RCDC, you're going to be able to generate the drawing. That's the way it looks like. That's why I prefer to go for. I have this software, but it's called Prokon, but I usually avoid it. But when it comes to stairs, it is quite a bit painful. And I think staircase is just standard. So there's no need for many engineers, sometimes those who have experience of many years, they don't design stairs. But for us, we must design and analyze it. But you can see for this software, it has standard stairs. If you go to, this is called Prokon, go to macros. So these are totally different software, not related to Staad Pro, but so far I've found it to be the best in terms of stairs. And even if you do manual calculations, you can just come and edit. So you go to macros, go to, see when you first use it. When you go to, let me open Prokon. I don't have a shortcut, so I just have to start Prokon. Right. So after you open the Prokon, you go to detailing. See, there's one analysis, you want to analyze. So I got detailing and then I go to parts. So I find this very helpful in staircase design, because staircase is just standard. As long as you just edit the dimensions accurately, then there's no need, because just standard. Let's open it. Okay. Then I go to and see here and open a new open and just go to macros. And then I choose staircase. Then you can see I can choose single flight, but this one I want is a double flight. So then I'll come on edit. Now my height was 2850, my landing this one was 1500, my riser is my going is 50, and top support is there to the right here. Top support. Landing support is there to the right. Then I have bottom support just to the right here. Then mirror, I want to mirror it. No. So I choose N. I don't want to mirror. Clockwise upward. Clockwise upward. So means this one is on the right side. Being it's clockwise, right? And then I will. So this spacing here is 200. So you can see my spacing main still is 150. My diameter spacing in secondary is 12. And if you can see, if you do manually, using RC design Excel sheet, RCC to 72. You can see you don't get values which are far from that, because you can see here on my flight 1, if for the same stairs. So actually let me show you. This is my landing is 50. Yeah, my landing is 50. Then all my landing is 50 till the top landing, and my riser is 150. my going is 50. My C is 200, and then A is 1200 as we have just indicated here. You can see, you can just follow here this A, then fill in your. And so when I go here, F1, where is F1? Flight 1. Okay. My story height is 2850. 2850 and 2850. I want to show you why Prokon is very helpful. So so my landing one is this, right? So my landing one here is I can say it's the first room, so it's just like that. No, landing one, my landing one is 1500. My landing two, so my landing two is very small, because there's just a beam there. There's a beam here. Remember, there's a beam here. Okay, so if there's a beam here, it means the landing can just be the size of the going. So I can just put 250, and you can see this one will be okay. And then my landing 3, you can see I got from the ground floor, I go to landing 1, then I go to landing 2, that is the first floor. Then I go to landing 3, that is the landing 3 typically. So landing 3 is still 250, and then I go to landing 4, which is second floor, and then I go to landing 5, and then I go to landing 6, which is fourth floor, 250, because there's I've decided to mount a beam there, to put a beam there. So 250. Now you can see automatically the Excel fills in my data. So you can see I get provide 5 H10 at 270 at 180 as 200 at 180. This is landing landing 2. Let me check. Landing 1. Okay, so you can see landing 2 is on the landing 2 is now on the first floor. You can see the distance here. Landing 2 is first floor, and I've decided that landing 2 is just landing 2 is just at 50. Okay. And then F1, what is F1? Let me check. So this one, F1 is basically the distance. So if I go here, if I go to my, let me check my view, I go to, so simply the distance from here to here. Remember this one was 250 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's approximately 2500. So we go like that. This is not 75 and 6. Let me check. There's another one failing. All of them are passing at 150. Okay, landing 4. Remember, landing 4 is very small, very small. Actually, landing 4 is not even there because it's a beam. So we don't have a landing because just it's a fixed, it's a beam that's supporting that slab. So this one is something very small. I can even just say 100 or 200 or just 100. Just something very small. So this landing is not even there because I'm landing on a beam. So you see the values I'm getting. Just H12 has passed, and this is the standard one. So it's better I use this. So I can just say okay, and then I can come maybe to my default. Maybe no. Maybe I'll come to my labeling. Maybe that's okay. Okay. I come here. I change this one font to Arial. And I prefer to use Arial. Then text pen 3, text pen 2, 5, text pen 2, 1, 3, line pen 2, 1. Then I can save this for default in. This height and just okay. And then you can see where my beams are placed, just here. So I can just um, just save, then I just print. So you can just print this. So this staircase is very standard. So I prefer Prokon parts to design my staircase. So I want to print PDF, DXL, right? And so I'm not going to print background colors. Go with I can change this to A1 size. So just use 8 or A1 and then print to DXL. And then I can change it and just save it somewhere. My local display, just save. Then I can come and then view it. Just open this. So still having AutoCAD as usual. AutoCAD it is known for hanging. Okay, yes, that's no problem. It is known. So let me check. I'm trying to hit escape, so whatever is the command, you can just ignore it. I can just edit my staircase here. Select similar. Remember I told you maybe you can just go to annotate and then text. Wait, just click the button there. And then I don't know if do I have area. Just add new and say area. And then okay. Okay, then I can come here and change it to area, and then I will put regular, not annotative, apply. Then I will add, then a new area. Okay, now come here and change it to bold and see, apply, and then close. Then come here select similar, and then I'll go to properties, change it to area, and this color and change it to black and white, and we're good. The rest you can edit, you can change the properties of this line. So you can see we have very good drawings of our staircase. Okay, so thanks guys. Please, I have showed you my tricks. Thanks, subscribe to my channel.